Hello everyone, welcome to Inspired Mechanical. In this video, we are going to study the basic concepts of projection of points. Based on that, problems will be asked in the examination. So what is the projection? Projection is basically image which is projected either on HP or VP. HP is horizontal plane and VP stands for vertical plane. These are the two principal plane of projections. And what is the point? Point is a circle of negligible radius. So a point may be situated in 9 different ways. Projection of points. First one is in front of VP and above the HP, which is also known as first quadrant or first angle of projection. And second case is point lies behind the VP and above the HP, which is also known as second quadrant, or you can say second angle projection. Third case is the point is lying behind the VP and below the HP, which is also known as the point is lying in third quadrant or third angle projection. Fourth case is point is lying in front of VP and below the HP, also known as fourth angle projection, or you can say the point is situated in fourth quadrant. So these four cases are very much important from the exam point of view. We will study these four cases very detail and rest of the cases in brief. So point number 5 is behind the VP and in the HP. Sixth case is the point is lying in front of VP and in the HP. Seventh case is the point is lying in the VP and above the HP. And eighth one is similarly point is lying in the VP but below the HP. Ninth one is in the HP and VP. Only one case is there, which is the point is lying on the origin. So one by one, we will study the basic standard procedure of drawing projection of points and the concepts also. So first case is just like that. This is the first case in which the point lies over here. This red color denotes our point, which is lying 30 mm in front of VP and 25 mm above HP. This 25 mm above HP and this 30 mm in front of VP will define whether the point lies in first quadrant or not. So here the observer is seeing this point from an infinite distance and the front view is projected on the vertical plane. This blue color denotes the front view, and denotation of front view is, suppose our point is denoted by capital letter A, front view will be denoted by small a having small dash on it. And when we see this point A from the top view, observer is right here where my hand is lying, the point will projected on the HP. Green color shows the top view, and for top view denotation, small a is the denotation standard. So what is the basic principle of drawing the projection? First one is rotate the HP 90-degree clockwise. Remember this point very carefully. Rotate the horizontal plane 90-degree but in clockwise direction. In this direction, the color shows a 90-degree clockwise direction. When we rotate the HP 90-degree clockwise, what we will get? We will get the HP and VP will overlap with each other. Second case. So third case will be the outcome of these two standard inputs, which will result in moving point A on the VP. This top view is moved to right here. So the final projection which you need to draw on your sheet will be just like that. This is the final solution. Draw a reference line XY with the help of H pencil, and this blue color denotes the denotation of 2H pencil. So the 25 mm above HP distance is projected on on vertical plane. So this distance will not be disturbed because we are keeping VP stationary. So this 25 mm distance, I'm showing you again, this 25 mm distance is projected on here on VP, and we are keeping VP stationary. So this distance will not get disturbed. But this 30 mm distance, which is lying over here, will be projected below the reference line XY, somewhere here, 30 mm. So this will be your final solution. 25 mm distance from here is the point of front view. Small dot you need to draw. write small a dash. This is the front view. And draw an extension line and do the necessary dimension of 25 mm. And just below that, over here, a point is drawn just like that. This is the top view of our point A, is lying 30 mm below the reference line XY. This is your final solution which you need to draw on your drawing sheet. Above case was to understand. So second case is the point is lying in second quadrant. So observer is saying from here, suppose our point is capital V, and when the observer will see this point, this VP need to be transparent. After that, we can see the front view and top view. So the front view is projected on VP. This green color shows the front view, small b dash. Because point is lying 28 mm above HP, so this 28 mm distance is projected right on the VP. From this point to green point is the 28 mm distance, which will not get disturbed because we are keeping VP stationary. Again, we apply the same principle, rotate the HP 90° clockwise. This red color shows the HP is rotated 90° clockwise. So the HP and VP will overlap, which will result in moving top view, which is shown by small b on the VP. So this blue color curve shows the movement of our top view. This top view, which is projected on HP, move to VP. So what will be the final solution? The final solution will be just like that. Draw and reference line XY with the help of H pencil and mark two dots. First one is 28 mm from the reference line XY, and second one is 24 mm from the reference line XY. So this small dot which is lying below the B dash of the top view, and this B dash is the front view. And do the necessary dimensioning, draw an extension line having 1 to 3 mm gap between this front view, and draw the arrowhead 1:3 and write 28 and 24 just left hand side of the final solution. So now move to third case. Third case shows the point is lying over here. This red dot denotes our point C location. So the point is lying behind the VP. This one is VP. Behind the VP but below the HP. So when the observer see from here, the front view is projected on the, so this green color, the green dot shows the front view denotation, small c dash. Because this 25 mm is the below HP distance, so this 25 mm distance projected over, which will not get disturbed in any case. After that, this 28 mm distance is projected on HP, because in top view we are seeing this point C is top view over here. Let me correct it little bit. Let me correct. Top view is projected over HP somewhere here. Okay. So this C move to here on the VP. Rotating HP 90° clockwise results in HP and VP will overlap, which will result moving point C on the VP. This point C, this blue dot move to on the VP. So what will be the final solution? This 25 mm distance will be drawn below the reference line XY, just like that. This will be the final solution. Draw an reference line XY, mark a 5 mm below dot here, shows the front view, to the necessary dimension 25 mm, just above it, 8 mm above the reference line. I mark an internal dot which denotes the top view. This is the necessary dimension and shows the 28 mm. This will be your final solution when the point lies in 28 mm in behind VP, 25 mm below HP, which is in the third quadrant. Remember that in second quadrant and in third quadrant, the principal plane of projection, which one is VP, because P is also principal plane of projection, but I'm talking about vertical plane. Vertical plane needs to be transparent. This is the most important question which is asked in competitive exams also. So now move to fourth quadrant. The point is lying 40 mm in front of VP, 25 mm below that. This red dot denotes our point location. So here observer is seeing this point. The front view is projected somewhere like that. This is the front view denotation. And when we see the point from here, the point P's top view is projected on HP. This will shows the top view. Okay. So applying the principle same, rotate HP 90-degree clockwise. When this HP is rotating 90-degree clockwise, what will happen? That HP and VP will overlap with this point P will result in moving on VP. So this one will be the movement of this right over there. After rotating 90-degree clockwise HP. So what will be the final solution? Final solution will be that this 25 mm distance will not get disturbed because this is projected over here, P dash. Okay. So draw and reference line XY and mark point 25 mm below HP and 40 mm below reference line XY. Same case as in second quadrant, but this time the projections are drawn below the reference line. In second quadrant, the projections are drawn above the reference line XY. Similar case. So this one is your front view, and this one is top view. Very easy. So now move to fifth case, which rarely asked in exam. So now move to fifth case. Point is lying in the HP. Point is lying somewhere here, but is denoted as behind the VP. Now the point is lying somewhere here. By capital L with red dot it is shown, and the observer when see this point, the front view is projected right on the origin and denoted by green small l dash. This is the front view denotation, and the top view lies itself on the HP. So small l denotes the top view. What will happen applying the same rules after rotating the HP 90-degree clockwise? This top view move to on the VP. So what will be the final solution? Draw and reference line XY, mark a point small dot here. It shows the front view, and 35 mm above we can show the top view of this particular point, and do the necessary dimensioning. This 35 mm distance will move to, okay, very easy. So now move to sixth case, just opposite of that. The point is lying in front of VP but in the edge. This red dot shows point P is 25 mm in front of VP and in the edge. When the observer sees this point, the front view is projected on the origin and shown with the help of small p dash. Okay. Now the top view. Top view will lie where the point is lying itself. There. Point is lying also on the red dot. So the top view is shown already where the point is. When we rotate the HP 90-degree clockwise, this small p is moving in this direction on the VP. So what will be the final solution? Final solution will be that draw and reference line XY, mark a point P dash anywhere on the line. This shows the front view. 25 mm below the front view, we need to show the top view of this particular point and do the necessary dimension. This 25 mm. Very easy. This one also. So now move to seventh case. The point is lying in the VP and above the HP. Point is lying in the VP and above the HP, somewhere like here. Okay, this shows the capital M shows the point's location, which is lying 30 mm above the HP but in the VP. Okay, and the observer will see this point where the point is lying itself shows the front view of this point. Okay, small m dash. And when we see the top view from here, the point is lying on the origin. This shows the top view, small m. So what will be the final solution? Rotating the HP 90-degree clockwise will result in overlapping of HP and VP, but this will not get disturbed our final projection. So final projection will be draw and reference line XY and mark a point small m, which is the top view on this particular line, and 30 mm above that draw m dash top view of this point. So the rotating of HP doesn't affect our final projection in this case and in upcoming case also. So do the necessary dimensioning 30 mm also. So this was the final solution of this case. This was also very easy case. So now move to Second last case. Point is lying in the VP but below the HP, somewhere here. Capital N denotes the point is lying 35 mm below the HP but in the VP. So rotating of HP doesn't affect our final projection here also, but where the front view and top view will lie. Front view will lie where the point is lying itself, but the top view is shown on the origin. When you see from here, from the top view, somewhere here, the top view is projected on the origin. So what will be the final solution? Draw and reference line XY with the help of H pencil and mark a top view with the help of H pencil, this dot. And this blue color shows the line should be very light and with the help of 2H pencil. And just below the small n and dash is also marked. Distance is taken as 35 mm. Okay. So now move to our final case. The point is lying both in HP and VP. Only one case is there. The point need to be on the origin. When the observer will see this point, the point is lying on the origin and front view and top view also lies where the point is lying itself. And this one is denoted by front view and this is the top view, P dash and P. So what will be the final solution? Nothing much. Draw and reference line XY, mark a dot here and write P dash and applying a comma and write the top view. You can write also in this manner also. P dash in bracket you can write P. Both are correct. Okay. So this was our projection of points basic concepts. We will meet in next video with another engineering drawing concept. Thank you.